Okay, my friends, once again, shocker du jour. What's the difference between asteroids, comets, and meteors? Well, let's ask a NASA science expert, and then we will see if we agree with that expert. All right, let's get started. Okay, maybe you haven't heard, but there's a big flyby of an asteroid, which is fairly good size. I don't know, school bus size, something like that, but it's no danger to Earth, they say. Now, let's see what NASA has to say about the difference between asteroids, comets, and meteors, because people really don't know. So let's listen to what they have to say, and then I will, of course, dispute it. That's what I do, because it's not right. Here goes.
In asteroids, comets, and meteors. Well, they're all planetary objects orbiting the Sun. An asteroid is a small rocky object, and when seen in a telescope, it appears as a point of light. Most asteroids are found in a ring between the orbit of Mars and Jupiter, called the asteroid belt. Some asteroids are round, some are elongated, and some even have a satellite. A comet also orbits the Sun, but unlike an asteroid, is composed of ice and dust. So when a comet gets close to the Sun, its ice and dust contents start to vaporize. So when seen in a telescope, a comet appears fuzzy and or has a tail. So what's a meteor? Well, let's start with a meteoroid. A meteoroid is a small piece of asteroid or comet, typically pebble-sized but could be a little smaller or a little larger, and often created from a collision. When a meteoroid gets close to the Earth and enters the Earth's atmosphere, it's called a meteor. And the meteor enters the Earth's atmosphere at a very high speed, so it burns up and produces a streak of light called a shooting star. So if you have seen a shooting star, you likely saw a meteor. And if a meteor survives the burn and lands on the ground, it's called a meteorite. So what's the difference between asteroids, comets, and meteors? Well, asteroids are rocky, comets are icy, and meteors are much smaller and are the shooting stars that you see up in the sky.
All right, let's talk about it. Okay, let's start with the first claim, is that an asteroid is a small rocky object. Well, I can't dispute that. Okay, I have some meteorites here, and this one here is an iron meteorite, the little one that came through space. This also is, and it's literally identical to this, as I will show you. And this one here is another one that came. This is a rocky meteorite. This is a, an iron meteorite, metal. So let's see what they have to say about asteroids, comets, and meteorites. And I will show you my evidence that is not going to support what they're saying. I can guarantee you that. Okay, my friends, buckle up. We're heading to space. This is NASA. Don't get nasty about NASA. Just let them have their words. It's only 1 minute and 26 seconds, and then I will present my evidence. And I have evidence to present, and it will be presented right here in all of the things from space related to what mud fossils are. Because you're going to find out things are not what you thought. So let's see what NASA has to say. Okay, my friends, so let's just start right at the beginning. The asteroid. What is an asteroid? Here's what it has to say. All right, let's talk about asteroids first.
Most asteroids are found in a ring between the orbit of Mars and Jupiter, called the asteroid belt. Some asteroids are round, some are elongated, and some even have a satellite. A comet also orbits the Sun, but unlike an asteroid, is composed of ice and dust. So when a comet gets close to the Sun, its ice and dust contents start to vaporize. So when seen in a telescope, a comet appears fuzzy and or has a tail. So what's a meteor? Well, let's start with a meteoroid. A meteoroid is a small piece of asteroid or comet, typically pebble-sized but could be a little smaller or a little larger, and often created from a collision. When a meteoroid gets close to the Earth and enters the Earth's atmosphere, it's called a meteor. And the meteor enters the Earth's atmosphere at a very high speed, so it burns up and produces a streak of light called a shooting star. So if you have seen a shooting star, you likely saw a meteor. And if a meteor survives the burn and lands on the ground, it's called a meteorite. So what's the difference between asteroids, comets, and meteors? Well, asteroids are rocky, comets are icy, and meteors are much smaller and are the shooting stars that you see up in the sky.
Okay, let's discuss those claims. Okay, as far as asteroids go, I can't really discuss too much about them because I really don't know if I have any what you consider asteroids. I guess most of the stuff I have that came through space is meteorites and magnetic iron meteorites and so forth, and the rocky meteorites. But what I really want to talk about is comets. All right, listen very carefully to what he has to say about comets.
Earth orbits the sun, but unlike an asteroid, is composed of ice and dust. So
All right, so he's saying comets are composed of ice and dust.
when a comet gets close to the sun, its ice and dust contents start to vaporize.
The ice and dust just starts to vaporize and blow away, they say.
So when seen in a telescope, a comet appears fuzzy and or has a tail. So what's a meteor?
All right, so let's just start with the comet, because I can show you that as a fact, that it is not what they say. Okay, you see what they say? The comets consist of ice and dust. This is not ice and dust, and I can tell you what it isn't either. This is not just a rocky body traveling through space and it's dust blowing off. You see that big, and you see all these little ones coming up here, and then you see these going out to the side in all different directions. Why do you think these all these little things? And why is it not cooking off of here? How come no dust is blowing off of the ball here? I can tell you exactly why. This is from 2015. I followed this just as close as the people that were in mission control. I can guarantee you that. I have every detail about this. They were wide open. European Space Agency, the Philae lander went up there and landed on this Comet 67P, Comet Gerensa, I can't remember how to pronounce it, but it's, anyway, Chiricahua or something like that. Now, I call it 67P, and that's the easiest way to do it. You see all these little tabs coming around here? They're not there just by accident. And all these little divots in here, they're not there by accident. And I will show you what this really is, and that is not what they say. It's not just rocky, dust and water vapor, ice. That, my friend, is biology. And I will show you what the particles are in there. I have all of this very, very well detailed. Here's what it is right there. This is what's blowing off. It's iron oxides, sodium, silicon, hydrogen, hydrocarbons. All of it's just bodily tissue that's coming out of there. And the reason they're pointing in the direction they're pointing in is because they are ejecting smoke from their little blood vessels. Every little tiny blood vessel. This is the. It looks to me like it's a tendon enthesis. Well, I know it's a tendon enthesis, and it has a muscle bundle. Let me show you that one. Let's find the muscle bundle. Here it is. Now, you got the anchor. All right. This is nothing more than residue of red, bloody flesh that's eroded and dried out and just collected here as red dust. This right here, that, my friends, is a bundle of muscle. And I've shown this to anatomists and so forth. Nobody disagrees with it. They just say, whoa, 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 wow. They're not going to stand up and say, oh, look out there, there's muscle in space. No. But they know, and they know these are the tendon enthesis. These tendons come down to the ball that anchors it. And in between is a little bitty stalk that has, that's where your tendon is. And this is a bundle of muscle that goes up so that this can flex. Now, I don't know what part of the body this is in, but it has all the characteristics of an ankle, to be honest with you. This ball at the bottom is like an ankle ball, and this is the, there's always a tendon, a muscle bundle that hangs off the side. And this is gigantic, gigantic stuff. You want to know how big this is the one that's really blowing out in space. Look at this, 40 meters across just this piece. So you got 40, 80, 120 meters. That's 360 feet approximately across. And that is the artery. And why do I say it's the artery? Because I see what it produces in space. If I can find it. Here it is. That's where the artery's shooting out. You see it? You have to have a huge amount of blood to service your foot and all that stuff. And I believe this is going right down into the foot. And these are the ones that run up to the muscles that surround the leg. Looks like to me, although I have no idea what kind of a creature it's from. It's in space, but everything I have found coming out of space is also biology. Now look at this. That's moon. I think it's Mimas or Tetchus, one or the other. But that's, you see this? That right there is where that anchor ball anchored. And this was a tendon. They're tendons. That's why you got all these little dimples, and then you got that one spot right here. That's where they break. That's the abrupt transition. Snaps right off. And that's what you're looking at right there. This one, and then there's another one next to it there's like a stalk and some blood or whatever. I'm not sure exactly what, but that is what you're looking at. And here's one in here. You're talking about, this is from NASA again, Lucy mission. Look at what they're looking at. That's it. How the planets grew and how they moved around early on. They have all these statements. Why won't anybody talk to Roger? I'm telling you right now, that is nothing more than a tendon enthesis. That's a ball and socket. There's some part of the anatomy that does this. This is not just an accident out there. And that central core there, this could be, that could actually be an apical tuft. Oh, that one around here somewhere. That's the tip of a finger. That's an apical tuft that sits right on the end of a fingertip. And all of these balls run down. Now that's not this, but it's not far off. That's a ball and socket in a body somewhere. And an anatomist might know exactly where it is. I don't know where it is. Now that's how big 67P is compared to Raleigh, North Carolina. That's the anchor. And that's the neck. And then it comes up to, this is where it breaks off and muscle tissue. Now, apparently there was a bone, well, usually there's a bone right in the middle of the muscle, so the bone appears to have been gone now, but at one time I'm sure it was there. All right, so we're talking about meteorites, and they come, iron meteorites. They're not really iron, they're metal. Now, all of these different crystal shapes are different types of metal, and primarily it's iron. That right there is blood. What's it doing inside of a meteorite? That's blood too, only that's the vein blood. Black is a vein, red is the artery. Why is it inside of a meteorite? Inside of all meteorites. That's a meteorite right there too. You know what that is? That's a lung. It's saturated with blood. I did a catalase test on it. It's bubbled like crazy. This is another lung. It's smaller, and it also came through space. You see that? It's identical. It's identical shape, you see? Exact same shape. It's just a smaller version of this. And it is also metal. It's not quite as magnetic. What happens is when they come through space, if you got a big one like this, it really heats up, and all the cheap stuff burns off. So you end up with mostly the heavy metals. Now, this burnt off pretty good. You know, it's just not real heavy, but it burnt off, you know, it's the temperature you achieve means how refined you get into the metal, how much smelts off, and the slag just goes pouring off in these little sparks and so forth. Now, this one didn't burn off as much, so it's not as magnetic, it's not so heavily metalled. This one burnt everything off, so it's very heavily metalled. Now, this is also a meteorite, and it came through space, but this is a rocky meteorite. It was not from like a lung or a heart or an organ. This is a fingertip from a giant. And you say, oh, Roger, come on. I say, yes, it is. And this is the bottom of the fingertip right here. Now, that little round spot right there is where one of the tendons meets up. There's another one here in the center and one here which exploded. You see this red? Exploded right off of there. Why? Because that is the side where the red blood comes in. Remember before I showed you, said one side the red blood comes in, the black comes back? These are wide open and they're just fluidy, and they exploded because it was wet coming through space. Exploded right out of there. This side, you see that? Look very careful. That right there is an artery, I mean a vein, and it has a clamp. That's why it didn't boil out of there, you know, the blood. Same thing here, that round one right there. That's also a vein, and it didn't blow out. There's a vein on the end that did not blow out either, and the artery on the end here didn't blow out either. Usually they do. They usually blow out both here and one on the tip. Now let me show you a terrestrial fingertip. That means one that came from here on Earth. Right here. That was in the flood. You see how flat it is on one side? It died just like that. And all of this blood ran out of here. Identical same fingertip. Even that spot, you see that? And that spot right there? It's the same spot. And even in the one I show you, in the giant one that's in my front yard, has that same spot. The other one is very well preserved, so it's just not run off like this. This had the red blood, which is the same place where this is the artery blood, just blew out because this came through space. It boiled and exploded out of here. This just ran out. It ran out of here, ran out of here, and ran out right out of there, and then congealed and turned hard. Those are the arteries. These are the veins. You see that? That's a vein, and that's a vein. They don't blow out. The same thing on the end. There's a vein on the end, didn't blow out. This one had this one blew out and just hardened up, and these two just ran right out. This is the skin that was on the top of this fingertip. This will have something very similar, but it's going to be hard to see because of most of the cheap stuff cooked off. You see how exactly identical this is. There's no question this is the same structure. There's your veins. Here's your veins here. There's that hook. You see the hook? Matey. And there's the there's the tip. And here's where the red blood blows out on the side. All right, coming from the end, coming in, we've got the center core. This one exploded right out of here. That's the center core on this one. This is the center core on this one. It didn't blow out. And this, of course, again, is the vein side. The artery's gone. Totally saturated with red blood there. Absolutely saturated. And that is full of the enzyme, which is catalase. All right, now again, I'm going to show you the other one that came from in my front yard. It has that same spot on it. That same spot. All right, there's another giant fingertips in my front yard. All right, I don't know if I showed you this yet or not, but this is one of the big fingertips I have laying around the property. I have them all over the place. I mean, literally everywhere. This is the vein side. This is the artery side. That's why it turns green like that. And it's just a big fingertip. Hold on. Let me see if I can. All right, now I'm going to show you. See all this stuff here? I maybe mentioned this before or not, but this is just, it must have died laying down soft on whatever tree branches or something. And I believe that is where one of the, either that's a tendon or it could be, no, I think it's a tendon. But watch this now. That's the tip of the finger. It's eroded and so forth. It's not heavily eroded. There's a lot of, and that may even be where the fingernail was. I'm not sure. I have these things all over my property. I have stone walls everywhere. And these are big, these are like chunks of fingers and things. You see these? Wherever you see that lichen, that's more than likely a vein blood. But it runs up there all the way up the back, and then way out in the back there's another fingertip. Well, let me just show it to you so you be sure you see it. All right, just take your time. This is the one that's in the back. Now, I showed you way up in the back. This has got to be, 400 or 500 feet or more away from where the other one was. Now, hold on one second. what I want to show you is the fingernail and the actual fingerprints. This is literally the fingernail. Now, it's hard to see, and I can't move it anymore. I moved it and it's upside down and I can't really see it well, and I hurt my shoulder when I did it. Well, alright, this is a fingernail. That's the fingernail. It comes down around just like it is on you. And there was skin right up to here, and I broke that off so I could get down in to get some blood out of here. This is the little pad that bumps up to your next finger. And this is blood supplies coming in. You know, vein and artery going in, coming back. And again, that's the fingernail. Now, I can prove this because it was fingerprints. The same thing, they start right next to your fingernail, just like they will on you. And here is what the fingerprints look like. This is the fingerprints, and it shows, and it popped right off. This is the grip skin, right there. See the fingerprints? That was on that fingertip. I smacked it so that I could get underneath. You can't get DNA off here. And I had this DNA tested, and it came back as mitochondrial human DNA. And they stand behind the test. Now, I took the sample by smacking into here and then drilling down into really literally red blood, and it came back saying the quality was excellent of the DNA. No contamination, nothing. Very dense and excellent quality DNA. And that's the fingerprints. Right up here was where the fingernail started. That's where I broke it off of. And that thing is about that thick. It's about maybe half an inch, 3/4 inch thick. But that's all this is right here. It's that keratinized heavy-duty skin. And that's what's called grip skin. And that's on Comet Moro, if I showed you. The same thing. It has a grip skin right on the very end. We're just dismissing all the things we should be looking at because they're just too spectacular for the average human mind to even consider. And especially when you're educated, oh, that guy's got to be insane. No, I don't. I pay attention to things, my friends. And I suggest that everybody else start doing the same. Just to dismiss something is, it's just not the way to do science. You cannot dismiss something without investigating. If there's material evidence, you got to examine it. Not being done for 10 years or more. And I'm talking about by Yale. Who will you expect to be engaged? They wouldn't even look at it. Absolutely refused. DNA tests meant nothing. Specimens meant nothing. Blood meant nothing. Same thing with Harvard. Same all of them. 100%. So you are looking for, you're putting your faith in people that have no, they're not taking care of you whatsoever. They are abrogating their fiduciary duty. Because you go to them to try to make more money as a, you know, to get educated, and you know, not only just get educated, you want to make more money. That's what a fiduciary does. They act in your best interest. This is not what's happening. Now, they may say, oh, it is in your best interest not to pay attention because nobody will hire you if you start talking about that. Well, that could be a valid point. Because people do, they shun you as soon as you go against people like at Yale and Harvard, which is, that's all they ever do. Because they're just not right, and they don't care about being right. They don't care about being right at NASA. They don't care about being right at Fermilab. They don't care about being right anywhere. It's all about the funding as far as I can determine. If I'm wrong, somebody just say, oh no, Roger, you're wrong. You shouldn't be saying this stuff, and here's why. No, that does not happen because there is no here's why. Okay, you might want to just take a look from space on Google Earth in North Africa about this gigantic fish that was being attacked by this gigantic dragon. And he spit all this nasty stuff down on the fish to obviously injure and kill him. And it did have a very negative effect on the fish's back. It ate right down into his vital flesh, and we can actually see blood vessels, capillaries, arteries, everything on his back. The black is the vein blood picking up at the capillary tips. That's what blood pressure is all about. Now, this is this is a battle that took place. It was recorded in the ancient text, and he runs all the way across exactly as what they said in the ancient text. His tail is way back here. These are dragon scales out here. So if NASA and all the rest of them want to be honest and true and teach us about our true past and about the history and what they can see from space and why this is just ignored. These are dragon scales. That dragon went all the way across North Africa, and he's on the maps from, I think it was 1387. Ran right all the way down here. This is his neck. All the way down, all the way down, all the way down, all the way down into his stomach. Now there was a terrible gash right there, and this is also recorded, and that gash is on the map too. And the reason this extremely green substance is running out of here is because that literally is draining some of whatever, got to be some remaining blood in this creature that is causing this to create this very extreme green growth. And this is all the red blood that ran out of there. This is all recorded in history. I'm not making any of this stuff up. If you want to go back and look at it, fine. If you don't, that's fine too. I don't really care at this point. But I'm pointing this out for people that should have been able to learn this in school, where it should have been taught. I've been showing this, or trying to, for 7 years minimum, to all the top universities. And they refuse to engage, and they've completely cut me out of the process because they have no way to respond to these things that I'm showing you. So you are being led by the nose by people that really don't care about you being educated. They care about you paying for your education, which to me is just not really much of an education. If you just have to say what they tell you to say, and you do, otherwise they fail you, and then you're not educated. So what is education? It's being able to say what they tell you to say. By the way, that's Atlantis. And there's the Straits of Atlantis right out here. It's not out the Straits of Gibraltar. This is where they were going in and out of the Sahara Ocean. That's what made them so wealthy. They controlled this straits. You couldn't get in there without going through there. And then it collapsed in one day, and I got a feeling it had something to do with this fight between this fish and the dragon. And Plato said every single thing ran out of here. The Cape Verde Islands were created out here, and it all went in one day. He said they will never talk about mud again. So if you want to listen to what your teacher's saying, I think that's a terrible mistake, and I think you should confront them, and I think somebody should. As far as I'm concerned, it looks to me like it's fraud now, because that's the legal definition of suppression of legitimate, credentialed evidence. If they can force that not to be seen, that is literally fraud. And I don't see one of them that will allow it to be seen. You say, oh, you go somewhere else and show that. No, you're the one that's selling this stuff to the kids, forcing them to pay for the rest of their lives for what you should have known was wrong. You should have investigated. I'm going to leave it at that. It always starts to burn me, and I really don't like to get into a bad mood. But boy, I'll tell you, it's hard to maintain just a happy, festive attitude when this kind of denial exists, and it's strictly to feed off of your kids, and maybe you yourself. I just don't think it's right at all.